You're sitting on a plane, cruising over the ocean, and the pilot comes over the speakers to say your ground speed is currently 480 knots. It sounds like a quirky pilot tradition, or maybe an old piece of sailor slang that refuses to die out. To understand why we use it, you have to look at the alternative. The mile you see on your car's speedometer is a historical accident. It started as 1,000 paces of a Roman soldier, a distance meant for tracking marches between milestones on solid ground. But when you leave the road, that system fails. Out on the open ocean, or tens of thousands of feet in the air, there are no road signs. There is nothing to measure your movement against. Surviving in these empty environments requires abandoning arbitrary human measurements for a system built into the geometry of the Earth itself. Back in the 1500s, navigating the open ocean was lethal. Without a way to measure speed, ships would miss entire islands, with crews running out of food and water while looking for coastlines that were actually hundreds of miles away. Sailors eventually solved this by tying a wooden board, called a log, to a long rope and throwing it off the back of the ship. The board gripped the water and stayed in place while the rope unspooled behind the moving vessel. They timed this with a 28-second sandglass, counting how many knots, spaced exactly 47 feet and 3 inches apart, slipped through their fingers. This worked because those numbers are a precise mathematical ratio. The distance between knots is the same fraction of a nautical mile as 28 seconds is to a full hour. Every time they did this, the navigator recorded the speed into a book. Since that piece of wood dragging in the water was called the log, the record became known as the logbook. Every time you log into a computer today, you're using a term that started with a piece of wood on a rope. This rope trick gave sailors a functional speedometer, but even with modern GPS and satellites, we haven't abandoned it. The reason lies in how we map the planet. Navigators divide the Earth into a grid of 360 degrees, creating a mathematical cage around the entire globe. Each of those 360 degrees is further subdivided into 60 smaller slices, called minutes, resulting in a total of 21,600 slices wrapping around the Earth. A nautical mile is the physical distance of exactly one of those minute slices measured along the surface of the planet. This makes navigation a simple matter of counting. If a ship is moving at 10 knots, it is traveling across exactly 10 minutes of latitude every hour. Unlike miles per hour, which is an arbitrary distance, the nautical mile and the knot are physical pieces of the Earth's geometry. This system allows a navigator to measure a distance on a map, hold it against the latitude lines on the edge of the chart, and read the distance in nautical miles directly. There is no conversion and no math required during a crisis. When aviation began in the early 1900s, pilots faced the same problem as sailors, crossing massive, featureless voids with no road signs. They treated the sky as an ocean of air, quietly adopting the sailor's toolkit of charts, latitude grids, and the knot to maintain their orientation. The world made it official in 1929, locking in the International Nautical Mile at exactly 1,852 meters. Even the United States eventually moved away from terrestrial miles for navigation, adopting the standard in 1954. Today, that standard is universal. Air traffic controllers in Brazil, hurricane forecasters, and the GPS satellites in orbit all speak the same geometric language. Miles per hour remains useful only where there are roads to follow. The knot survives at 35,000 feet because it is the only unit that forces the machine, the map, and the planet to perfectly agree.